first layer at the bottom of the OSI reference model. It is the layer in which the actual communication takes place from one system or one host to another host, wherein the raw bits of data are transmitted in some particular fashion. And then you have also studied what are the different physical layer media or the communication medium or communication options available, then the channels that are available, then how or what are the different methods in which the data is transmitted in the physical layer using any of these channels. Then you have also studied, after that you have studied about the data link layer. Data link layer you must have done really well, right? So many things that come into picture in the data link layer. The data link layer is subdivided into two layers, or it is divided into two sub layers. That is the MAC, that is medium access control layer, and the other one is the logical link control layer. Again, under that you had done, or you studied things like bit stuffing, byte stuffing, then what is character count, then what is CRC, what is checksum. These are the different things that you have studied in the first layer, that comes under the logical link control layer. Then you have also done the medium access control layer, wherein you've studied how the systems try to access the medium, or they try to access the channel, in what are the different methods available, or how are these systems connected, and how do they access the channel, and why accessing the channel itself is a very important task for any networking system, right? Again, under that you have done things like CSMA CA, CSMA CD, you've done the Aloha protocol, you've done slotted Aloha protocol, then you have done 802.3, that is the Ethernet, which uses the CSMA CD protocol. Then you have also done what is token ring and all that, right? These are the different concepts that you have done so far, some of the concepts that you have done so far under communication networks subject, right? So now we move on to the next layer, that is the network layer. So we move on to the network layer. Network layer is the third layer in a communication system. Just before I move on, let me share the file with you. Okay, now this is the document given by RD sir himself. So it is his document which I will be sharing. I hope you are all able to see this. Are you all able to see this? Are you all able to see my screen?
Yes, ma'am. Yes, ma'am.
Okay, just give me one moment. Okay, I'll have to start from the beginning. So this is, as I already mentioned to you, these slides have been given to us by Dr. Ravila Dili sir, and the same, we are just maintaining the same thing so that we maintain uniformity throughout. Okay, and so the topics that we will be discussing under the network layer. Network layer is another extremely important layer when we talk about a network as the whole. Its functionality is so diverse that it kind of tries to accommodate every function or most of the functions that is possible, right? Now, design issues, as you can see from the slide, design issues and services. What are the issues that you would be facing when you have, what are the issues that you would be facing in the design? That is, now you think about this whenever you are trying to learn these concepts, you try to learn it in such a way that you are deploying a network. Okay, so now from when you are deploying a network, you started with the physical layer. So therein you have created the channel, you have decided what is the channel you will be using, you've decided what will be the bandwidth requirement, all that you have decided what should be the data rate, all this you have done. And then you moved on to the data link layer. In the data link layer, you decided what will be the bit stuffing or byte stuffing, or what is the security feature you're, or the crypto, how are you going to check for the error correction or error detection, what is the algorithms you will be using, all this you decided in the data link layer. After that, now coming up to the network layer, the network layer is responsible for all these concepts that are mentioned in this slide. The services that the network would provide, or the services that the system would provide to you, to the end user, to the intermediate users. Then the routing algorithms, routing or routing, however you pronounce it, these algorithms are very, very pivotal to the network. Why are these routing algorithms required, or what is the essence of these routing algorithms? Routing algorithms decide how or through which path the packets have to be sent through. Why is this important? Now, as we are all already aware of, the data that we try to transmit from one point to the other point does not go as one big file that is as it is generated. Right? Now, let us say, for example, a very simple example, you create an email. An email that you create as one package would definitely not go or not reach the destination as one whole packet itself, one whole package itself. What is done? It is broken down into some blocks of data or some chunks of data, and these blocks of data are further tried to they are transmitted across the network to reach the destination. So when we say that they have to be transmitted across the network to reach the destination, we should definitely know which path you are going to take, right? Which path is each packet going to take? There are multiple hops that the packet would take up before it reaches the destination. Okay, so how is the router, or how is the network layer equipment going to decide what should be the route that each packet should take, what should be the next hop it should take? This is decided using the routing algorithms. Okay, for example, a very simple example for this is when you have to go from one place to another. When you have to travel from one place to another place B, from A to B, you would have multiple routes possible, right? Multiple routes available to you to reach your destination, that is B. But how do you choose? How do you select which path you would like to take? That depends on various various possibilities, right? Let us say I would want to go through a path which takes the least time for me. Or if I am very eager to, I cannot go by bus. I do not have any other means to go. I have to go by walk. Then obviously I would definitely take up the the path that has the least distance, right? Or the least cost, right? So these are the different measures or measurement metrics that I will use in order to decide which path I have to take. So accordingly, routing algorithms are also given to us on the basis of these different criteria or measurement metrics. Another simple example, you use Google Maps day in and day out, right? Google Maps, anywhere you have to go, you go to the Google Maps and you try to find out what is the best route. How does Google Maps give you the best route from one point to another? Again, Google Maps also makes use of one of these, something like routing algorithms. Okay, this is the importance of routing algorithms. Next, moving on to the next topic, that is congestion control algorithms. What is congestion? We make use of routers very frequently in a network, right? A router is supposed to route the packets that arrive into it to the appropriate line that is best suited for that packet to be sent across to the next hop or to the next to the next equipment unit. So this is a very important feature of it is a very important function of the router. Now, having said that, when we've got numerous routers and other equipment in the network, there could be congestion in some point of the network which would affect the communication from our end also, right? So when we look at the entire network as the whole, a congestion in some point of the network might as well affect the communication in some other part of the network, right? So that is why congestion control algorithms are also a functionality of the network layer, right? So it is supposed to find out where is a congestion. Something like, again, going back to Google Maps, there is a traffic. You find out that it gives you the traffic in different colors, right? Maroon, red, green, orange, and all that. So how is it that you decide how to go based on all these? Correct? If there is a congestion in the route that you are regularly taking, you obviously try to go through a different route, isn't it? You don't want to go and get stuck in that congestion again. Same thing over here. The network layer tries to, or the router in the network layer tries to find out alternative paths. It tries to find out where there is a congestion, where there is a bottleneck. It tries to minimize the congestion in some with some algorithms, and these algorithms are known as congestion control algorithms. Next, QoS. QoS is quality of service. Quality of service is again another very important factor or important concept in the network layer. You all must have experienced something called jitter, right? You must have experienced something called jitter. What is jitter? Jitter is, there is a difference between end-to-end delay and jitter. What do you mean by end-to-end delay? You try to, the file is available in the server. You want to download a particular file, or you want, let us say you want to watch a particular video. When you want to watch a video, if you are downloading, how long does it take for the entire file to get downloaded? That gives you the end-to-end delay. Whereas what is jitter? Jitter is something like, again, coming back to watching a video. You might have experienced this, wherein there is some video that gets down, or that you're able to watch, or that gets downloaded very fast, and then you have to wait for a longer time to obtain another few seconds of the video. Again, a different waiting period to obtain another few seconds of the video, and all this. This is known as jitter. Uneven delay is called as jitter. All right. Quality of service has to be maintained, and it is taken care of by the network layer. Then Going to IPv4, IPv6 addressing. Remember, initially all of us, of course even now we still do use IPv4 addressing, but given the number of systems or the number of equipments or the number of systems that are getting added into the network, today we talk about Internet of Things and all this, wherein so many number of users or number of equipments or number of systems are getting added into the network as a whole, right? Then each one has to be given an address, a network address. Initially it was IPv4. Since the number of systems getting added is increasing at a very large rate, high rate, day after day, the IPv4 addresses started becoming very less, or it was not sufficient for so many number of systems. So therefore, the world is shifting to the IPv6 addressing. IPv6 addressing is a 64-bit addressing, whereas IPv4 addressing is just a 32-bit addressing scheme. And of course, we are moving on to IPv6. Most of the systems that we buy today will come with IPv6 address. However, it would be compatible with the IPv4 addressing also, because most of the networks still do use IPv4 addressing, and they have not, or we have not completely moved to IPv6. And the last one is unicast routing protocols. Unicast routing protocols, unicast is nothing but one-to-one routing protocols. You have got BGP, you have got OSPF and all these other protocols. So these are the topics that we will be discussing in detail under this particular section about network layer. Now moving further, similar to what I have already discussed, the responsibility of the network layer is what? It is responsible for getting packets from the source all the way to the destination. It should take care to choose the routes to avoid overloading or to avoid creating bottlenecks, etc. In some of the communication lines. And the network should also know the topology of the communication subnet. Now, some of the essential functionalities are routing, forwarding, priority and scheduling, and some other functions. What is routing? I already told you, it is a mechanism for determining the set of best paths for routing packets, and it requires the collaboration of network elements. Then forwarding is when you are trying to send a packet from one point to another point. You may not be the destination at all, but the packet has arrived onto you. Then what should you do? You should find out who the destination is and you should just forward that particular packet, right? So that is forwarding. You transfer packets from the network elements input to the output. Then priority and scheduling. You have to find out what sort of a packet is it? Is it something that has to be delivered to the destination immediately without any delay, or is some delay allowed on that particular packet? For example, usually when you are let us say for example you make a video call on WhatsApp, or you try to make an audio call on WhatsApp or any of these applications. These are high priority. They have to be given high priority, where that is, you do not tolerate delay in such applications, right? Let us say instant messaging, you don't really tolerate any delay in it, whereas when you're trying to send an email, some micro or milliseconds of delay is still tolerable in that case. So you have to, the network layer is supposed to find out what is the kind of packet it is trying to forward or it is trying to send, and accordingly it has to prioritize and schedule it. Some of the other optional functions that the network layer takes care of is congestion control, segmentation and reassembly. Segmentation is to break down with some particular rule. Reassembly is to put back all these segments to create the actual data. And then you have got some point of security also. Now, this is a figure that shows you the environment of the network layer protocols. This is also known as store and forward packet switching. Now, just look at this figure. What do you understand? You have a host 1, that is H1. This is host 1. And you have another host, which is H2. Now, the host 1 runs a process known as P1 and host 2 runs a process known as P2. Now you just look at host 2. It is connected from the node F using a LAN, right? So what is happening here? Well, there is a packet 1, which is being sent into the network. This is the entire equipment, carrier's equipment. Then this is known as a router. So there are so many equipments, or there are so many elements within the network. Now, what should it do after once the packet 1, the packet that is numbered 1, starts from A, it reaches C. It has to find out from C where should it go to, right? If it is itself, then it is a destination, well and good. But now we know that the packet, let us assume, has to go to host 2. Host 1 has sent it to host 2. So once it arrives at these particular intermediate nodes, these nodes will just store those packets and then forward it when the time is appropriate, right? This is known as store and forward packet switching. Again, let me reiterate, circuit switching and packet switching you must have already studied earlier also. Now, this is how it implements a connectionless service, right? Now, a connectionless service is when we do not have a direct connection from one host to another host, whereas there are multiple routes that are possible in between. Now, look at this. This is known as a routing table. The tables that are mentioned here, these are known as routing tables. These tables are updated very frequently or periodically. All right. What you understand from this? Look at the first set of table. It is A's table. This is the table that A has stored in itself. Okay. Initially, these are the different nodes in the network: A, B, C, D, E, and F. You look at the network. You've got A, B, C, D, E, and F. These are the different nodes. Now, in order to reach these nodes from A, what would be the next hop? That is what this table has got. So if a packet has to reach from A to itself, then it is to itself. If it has to reach B, then what does it do? You see, there is a direct connection to B from A. So the next or the destination line would be B itself. Similarly to C, A is directly connected to C. So the next line would be C. If it has to go to D, let us say if it has to go to D, then what does it do? Through which node should it go? It will have to decide. According to this, it goes to B and then from B to D. So the next hop is B. Okay. Similarly, this is another important concept under routing, which is known as a routing table. All the nodes within a network, every single node within a network will have a routing table stored in itself. This routing table is available, or it is made available to all the other nodes of the network. Okay, every node forwards its routing table to all the other nodes in the network, so that the other nodes can also update their routing table according to the one that they have received. Okay, this is now let us see what is implementation of current connection oriented services. What happens in a connection oriented service? It should have decided the path that it is going to take. It cannot decide at an intermediate time as to which path it is going to take, because it is connection oriented. Though there will not be any physical resources made available for this connection, but it is known as a virtual circuit subnet. What is virtual circuit? It just means that now let us say host 1 and host 3, both of these are sending packets to node A to send it to the host H2. So now what does it do? This is going to decide which route should be given to these packets. Okay, so accordingly you see packet 1, packet 2, 3 and 4, they are all going to go through the same path. They will not change the path. Okay. Whereas in a connection-less service, you see packet 1 was sent through some path. Now packet 1, 2, 3 have been sent through this particular path, that is A, C, E and F. Whereas packet 4 is being sent through B. Okay, then it goes to D and E and etc. So here connection less services, there can be a change in the route, whereas in connection oriented services there is always a route that is established between the two hosts and all the packets are sent only through this particular route. So here is some comparison between datagram and virtual subnet networks. Datagram subnet, is there a circuit needed? There would not be a circuit needed because it is sent as a datagram and packets can be sent through any route. Whereas in a virtual circuit subnet, there is a circuit required. Again here, a circuit need not be a physical circuit or physical connection between the two, but a virtual connection. Then what happens to the addressing? Each packet will contain the complete source and destination address is required. Why it is required? Because each packet can be sent through any route, correct? So the packet, every packet that is sent will definitely require the complete source and destination address in itself. Whereas in this virtual circuit subnet, only the virtual circuit number would be sufficient. The packet number and the virtual circuit number will be sufficient. So then reassembly is very easy at the receiver. What information does it hold? The routers in the datagram subnet, the routers do not hold the state information about the connections. That is, they do not know whether that particular connection is existing or no. Whereas in a virtual circuit subnet, it is definitely required because you are going to connect, you are going to use the same circuit throughout the communication. Routing, each packet is routed independently, whereas in this case, the route chosen when the virtual circuit is set up, all the packets are going to follow the same route. Then what is the effect of router failures? What happens if any of the router inside the subnet fails? What happens? Only the ones that were going to that particular route, that particular router, only those packets are going to fail, right? Only those packets, except for the packets that are lost during the crash, you're going to lose. But otherwise, since the other packets might have reached from different paths, through different paths, they will definitely be received at the receiver. Only those that went through the failed router path will be lost. Only those will have to be retransmitted. Whereas what happens in this case, in a virtual circuit subnet, if one router in between in that virtual circuit fails, then the entire route, all the packets that were there in that route will have to be retransmitted. All the communication will be terminated and you will have to find out a new virtual circuit once again. What is the quality of service that you can expect in a datagram circuit? It is difficult to answer. You may get good quality of service, but it is difficult to achieve a very good quality of service. But what happens in a virtual circuit subnet? It is better. It is easily achieved if there are enough resources that can be allocated. Similarly, congestion control also, since all the resources in that route will be accommodated or it will be allocated only for this particular communication, obviously you need not really worry much about congestion in that particular line. This is about a comparison between the datagram and virtual circuit subnets. Now, coming to routing. Routing, as I said, is a very, very important concept in the network, in a network. In our course, we try to study about two routing algorithms. One is known as Dijkstra's algorithm and the other one is known as Bellman-Ford algorithm. For those of you who had the opportunity of starting our lab just a few days ago, in the CN lab, you must have, some of you at least definitely must have done this. Can you recall what you had done? Yes, anyone who can answer?
Some batches were given slotted Aloha protocols, but not all of them were given the routing protocol.
Yeah, I understand. From those, only those who had done, can you recollect?
Dijkstra's algorithm and a couple of other algorithms.
We've done Dijkstra's algorithm and Bellman-Ford algorithm.
Yes, ma'am.
Can you recollect what was done, or
Ma'am, what we were basically doing was we were making a table, or like we were creating a table in each router, which would basically show like which is the, like it would keep iterating each time, and it would find out which was the shortest part to each destination and store it in, like keep that table with itself. So whenever it actually had to send something, it would basically just look it up in the table and then use that part to.
Correct. So you're trying to find out the shortest path between any two nodes. Correct. So we are making, one was Dijkstra's algorithm and the other one was Bellman-Ford algorithm. Both of them, as you just rightly mentioned, we try to find out the shortest path between any two nodes, or between one node and all the other nodes in the network. Right? So let us just recollect again all that. Now what you see on this is known as a graph. Right? This is known as a graph. Now, what you understand from this graph, let us say these numbers that are written on these lines are the weights, or they're also known as cost. Okay? They are also known as cost. For example, let us say these are the cost that this is the cost of the ticket that you buy when you have to go through these particular routes. Okay? So now what you do, you have to find out. Now I want to travel from say point 1 to say point number 5. I want to travel from node 1 to node 5. If I have to travel from node 1 to node 5, what would be the path that I should take, through which I am going to spend the least amount of money? Right? So what do? The first thing that I will see is whether there is a connection, direct connection from myself from this point 1 to point 5. Is there a direct connection from 1 to 5? There is no connection. Right? Also, I know the cost only to those nodes with whom I am connected to. Isn't it? I know the cost of only the nodes that I am connected to. The nodes that I am not connected to directly, I do not know the cost to that particular node. Did you all understand this? Did you all understand what I just said?
Yes, ma'am.
Okay. So now observe just try to understand this graph. Node 1 is connected to node 4. It is connected to node 2 and it is connected to node 3. Right? Node 1 is connected to node 4, node 2 and node 3. So from 1, I can immediately go only to these 3 nodes. I cannot go anywhere else directly, right? I can hop to 4, or I can hop to 2, or I can hop to 3. Now, which among these 3 would you choose? For that, you have to try to okay, just wait, let me try to get a presentation so that I'll be able to write something and show. Are you all still able to see the this one, the PDF only?
Yes, ma'am.
Then I'll have to switch over the window. Now I think you're all able to see the presentation slide.
Yes, ma'am. You can see.
Now all right. So now I want to travel from node 1 to node 5. What is it that we do? We do not know the distances to all the other nodes. So what you first do is initially I'm going to make all of them as infinity. Initially I'm going to consider all of them as infinity, because I am just at the beginning and I do not know the route to any other node. Okay, now I decide that the source is node number 1. So if the source is node number 1, now I start to find out which is my neighbor or who is my neighbor and what is the distance to my neighbors. From this I can make out my neighbors. Who are my neighbors? 4 is my neighbor, 2 is my neighbor and 3 is my neighbor, right? So what is the distance to 4? The distance to 4 is 10. What was the distance existing? It was infinity. Infinity is greater than 10, or put it the other way, the cost that I've calculated now is less than what was existing. So what I do, I will update this as 10 comma, sorry, this is 1, not here. 10 comma 1. What does it mean? What does this mean? I update this as 10 comma 1 and I also update this as 20 comma 1 and I also update this as 30 comma 1. What do you understand from this? I have only seen who my neighbors are and I have updated the distances of my neighbors. Okay. Now, I have already visited all the nodes that the working. Now, 1 is where I'm working from. So I call this as the working node. 1 is the working node. From the working node, I have visited all the neighbors of the working node. Where do I go next? You choose which among all these values is the least value. This is 10, this is 20, this is 30 and this is infinity. Which one is the least among all this? Which is the least among all this? It is 4, isn't it? Why 4? Because the cost of 4 is 10, whereas the cost of 2 is 20 and the cost of 3 is 30 and the cost of 5 is infinity. So among all this, 4 is the one that has got the least path or the least cost. So now I make 4 as the working node. 1 from 1 I have already visited all the nodes. So I make this, or I call this as a permanent node. I call this as a permanent node. Fine. Now starting from 4. From 4, who are the neighbors of 4? 4 you see is connected to 5. 4 is also connected to 3. 4 is not connected to 1 in this direction, whereas 1 was connected to 4. But 4 to 1 there is no connection present. So now 4 is connected to 3 and 4 is connected to 5. Can you relax the values? Just see what will happen. 4 is connected to 3. What is the weight or what is the cost of 3? It is 30. But look at what happens to this. I have got 10 plus the cost of this particular line is 5. So 10 plus 5 gives me 15. 15 is lesser than what was existing over here, which was 30. So instead of this, I am going to update this value as 15, 4. Could you understand this?
Yes, ma'am.
All right. Next, who is the other neighbor whom I can look at from 4? I can look at node 5. What would be the cost? 10 plus 20. 30. 30 is less than what was existing here. So I am going to make this as 30, 4. Okay. Now from 4 I have already visited all the nodes that I am connected to. So now this also is called as a permanent node. Now which will be my next working node? Which one should be my next working node? 4 is a permanent node, 1 is a permanent node. I've got only 3 more nodes left, that is 2, 3 and 5. You check which one has got the least cost among these 3. The cost of 2 is 20, the cost of 3 is 15 and the cost of 5 is 30. Which one is the least among these 3? It is 3. Correct? So I make 3 as the working node. 3 becomes the working node. Now what do I do? We see that 3 is connected to 4 whose cost is 10 and 3 is connected to 5 with the cost 20. With cost 20. Which one can you relax? Look at this. What is the existing value? It is 30. But what will happen if I relax this? 15 plus 20 is what? It is 35, which is greater than what is existing here. So I am not going to do anything to this. Right? The same is what we are going to use in this example. Let us go on looking at the example. And I will also try to explain those steps. So now coming back to this file, what do you do first? The Dijkstra's algorithm, it finds the short path from a given node to all the other nodes in the network. And this node S is also known as a starting node or an initial node or the source node. It starts by assigning some initial values for the distances from this particular node to every other node. What did we do? We tried to initially we tried to make all the nodes as infinity, right? And then it operates in steps where at each step the algorithm is going to improve the distance values that are existing. Now, so what is the first step? Initialization. For this particular source node from where we are starting, source node or starting node, we take its value as 0 and we also label it as permanent because we don't want to come back to the same node again and again. Next, you assign to every node a distance value of 1 and label them as temporary. You either give it as 1 or you make it as infinity. In some textbooks, it is given as infinity. In some places, it is given as 1. However, the further steps is what is important. Next, you designate the node S as the current node or the working node that I was mentioning. After that, you go on updating the distances on the basis of what you look at this. This is the expression or equation you use when you have to improve or update the distances. What is it? The new distance will be equal to the minimum of existing distance and the distance that is calculated right now, isn't it? Yes, what did we do? Here we took it as, let us say here we had some 15. We got a value as 15. How did we get that 15? We found out the minimum of what was existing, it was 30. And what did we calculate? We calculated it as 10 plus 5, 15. Which is the minimum of the two? 15 is minimum between what was existing 30 and what we've got now is 15. So that is the minimum. That is what is given over here, where Cij is the cost of the link I comma j as given in the network problem. These steps are mainly meant for the programming perspective. Okay, of course, this is what you have to know, this equation. Otherwise, you can definitely just directly solve. You need not really write down all this at any point of time. Okay. Next, when do we stop? If all the nodes that can be reached from node S have been permanently labeled, then we stop. If we cannot reach any particular temporary labeled node from this particular node, then all the temporary labels become permanent and we are done. Now this is again the program part of it. I would want to give you examples better. Yeah, this is an example. I want all of you to please take a paper and a pen. I will explain only one example in this class. The rest we will do in the next class because it's almost time. Since we started with Dijkstra's algorithm, I just want to finish off with one example. Okay. So just take a pen and a paper. Draw this graph. Now look at this. The problem is you find the shortest path from node 1 to all other nodes using Dijkstra's algorithm. Okay, so 1 is the source node. You have to find the shortest path to all the other nodes using Dijkstra's algorithm. Let us start. What is the first thing? The first thing is the source node has to be given as 0 and it is marked permanent. And all the other nodes, we do not know the root to, we will consider it as infinity comma temporary t. Okay, infinity because we do not know the root. Right, that's the first step. Next step, look at what 1 is connected to. 1 is connected to 6, 1 is connected to 3 and 1 is connected to 2. Right? Update those particular node costs. So what would be the cost for 6, node 6? The cost of this link is 14 and what is existing is infinity. So what is the new cost? New cost would be 14 comma t. The new cost would be 14. Similarly, from 1 to 3, what will be the cost? It is 9. At 1, we've got 0. Cost of 1 is 0. And cost of the link between 1 and 3 is 9. 0 plus 9 is 9. What is existing at 3 is infinity. So what we've got now, that is 9, is less than infinity. So the cost at 3 will be replaced by 9 comma t. Next, again, the cost of node 2. Node 2, what has happened? Initially it was infinity. Now the cost is 7. So I'm going to improve it, or I'm going to replace it as 7 comma t. Is that clear? Further on, what do we do? You have to choose which of these is the least one. What are the three? What are the weights we've got now? We've got 14, that is the weight of 6. We've got 3, whose weight is 9. We've got 2, whose weight is 7, and the other 2 are infinity. Which among these is the least one? 14, 9 or 7? 7 is the minimum, right? So you are going to choose 7, which is at node 2. From node 2, again you have to try to change the other nodes. Okay. Now, node 2 now becomes a permanent node. What can you change to from 2? 2 is connected to 3 and 2 is connected to 4. 2 to 3, the cost is 10, right? Whether you will change the value at 3 or no. What would be the total cost of this particular link? The cost of 2 at 2 is 7 and the cost of the link between 2 and 3 is 10. 7 plus 10 is equal to 17, which is greater than what is already existing at 3. So therefore, we are not going to make any change. Okay. Next, 2 is connected to 4. What happens over here? The cost at 2 is 7 and the cost of the link between 2 and 4 is 15. 15 plus 7 is 22. 22 is less than what is existing at 4, which is infinity. Therefore, at 4, I am going to replace infinity by 22. Okay. Yeah, so that is what is shown over here. Is it clear? Next, what you do? You have to choose again. 1 is a permanent node, 2 is a permanent node. You are remaining with 6, 3, 5 and 4. And the cost of 6 is 14, the cost of 3 is 9, the cost at node 4 is 22 and the cost at node 5 is still infinity. Which among these is the least? It is of course the cost of 3 is the least one, right? So you go to node 3. Node 3 is now the current node or the working node. You try to emulate the neighbors of node 3. Who are the neighbors of node 3? Node 3 is connected to 6 and 3 is connected to 4. 3 to 6. What happens? Can you change the value at 6? Let us see. Cost of 3 is 9 plus the cost of the link between 3 and 6 is 2. 9 plus 2 is 11. 11 is less than what was existing at 6, which was 14. But what we've got now is 11. So therefore, this value you can update. Correct? Next, 3 to 4. What happens to this? The cost at 3 is 9 and the cost between cost of the link between 3 and 4 is 11. 9 plus 11 gives me 20, which is again lesser than what is existing at 22. Therefore, this also I can change. Right? Let us see. Could you make out? Node 3 to node 6, existing was 14. What we've got now is 11. Node 3 to node 4. At 4, the existing weight was 22. Now we've got 20, which has been updated. So now 3 is also become a permanent node. It's done. You need not go back to the permanent node at any point of time again. Now you choose which will be the next working node. 6 is 11, 5 is infinity, 4 is 20. Which among these three is the least? Of course, it is 6. So at 6, go to 6. 6 is connected to 5. 6 is connected only to 5. It is not connected to 1. You cannot go back. This direction is not available. So 6 is connected to 5. How would this change? The cost at 6 is 11 and the cost between the link 6 and 5 is 9. 11 plus 9 is 20. What is existing at 5 is infinity. So therefore I can change it because 20 is less than infinity. So the cost at 5 would become 20, t. Right. Next, 6 is not connected to anything else. So now at present the values that we've got are 11, 20, again another 20. 6 is already a permanent node. It is done. The other two are both 20, 20 and 5 is not connected to anything else, whereas 4 is connected to 5, but 20 plus 6 gives me 26, but what is already existing at 5 is lesser, which is 20. Therefore, there is no change further. This gives me the final cost to all the nodes with respect to node 1. So what you understand, from node 1 to reach node 6, the total cost is 11. You just observe this graph, you see that nodes 1 to 6, there is a direct connection, but its cost is 14. But if you go from 1 to 3 and then 3 to 6, their cost is lesser. It is 9 plus 2, that is 11. So obviously, this becomes a shorter path when it comes to cost or weight. Okay. And 1 to 2, the cost is 7. 1 to 3, the cost is 9. 1 to 4, the total cost is 20. If I have to reach from 1 to 5, the total cost is again 20. And if I have to reach from 1 to 6, the total cost is 11. This gives me the final answer. Okay. Now I want you to make a note of this particular graph. Okay, you have to compute the shortest path from A to Z. A to Z. Please make a note of this graph. It is an undirected graph. Okay, so you go only in one direction. You need not go backwards at all. So you take only one direction. Please make a note of this. Meanwhile, I will download the attendance. Okay, so with this we shall end today's class. But before we move on, let me stop recording. All right. Now, since I just got this opportunity to meet you all of you together, in fact, all the sections together, given that you're all in the 6th semester, I want to mention a few points over here, being the industrial training coordinator. I hope all of you are listening to me.
Yes, ma'am.
Okay. Now, first things first, I really appreciate Mr. Dhruv. I can't really recollect your complete name, your full name. Let me see. Yeah, I find that. Dhruv Balkrishna Salwadi. He sent a very detailed email regarding what are the common questions that most of the students have with regard to the industrial training. I have created one file with all the answers to all the questions that you have put down. I will circulate that just tomorrow morning or by tomorrow afternoon. I really appreciate your effort in writing that mail to me. Next. Many of you are very confused. I really don't know why. First thing, one more thing is, please address all your queries either to myself or you please write them to Dr. KMN. Okay, please put your emails only to myself or to Dr. KMN. And then third, the minimum duration of your industrial training has to be 4 weeks. If you have already taken up some work somewhere before this, if you have already completed a 4 weeks training, then you can definitely present that as your industrial training part. You need not do it once again just because we have pointed out or we have reminded you about it now. If you have already completed, then it is well and good. Of course, a completion certificate, the training completion certificate from the trainer or from the company that offered the training to you is a must. You have to submit the certificate along with your report, and you have to present the work that you have done or what you have learned from the 4 weeks training period. Clear? Now, some very few of you were asking why only professors from Department of ENC and all that. This is again, let me just reiterate. It is called industrial training. The concept of industrial training is for you to get an exposure to the industry, to train yourself, to work in an industry further on and all that. Providing some work as part of the industrial training, providing a mini project as part of the or for an industrial training in an academic setup. This is only due to the ongoing pandemic scenario. Okay, otherwise, normally we definitely encourage you to go into some internship or some company or industry only. All right, so since we have enough faculty who are already working under different projects, we definitely want you to take up one of them, some project under them, also because you are also in the same department, you don't belong to some other department. Having said that, it is not mandatory. If you find some good projects being offered by any other faculty members from other departments, then, and if you are not comfortable with any of the projects that are being offered from our department, if that is your last choice, then please take it up. You can do it under anyone. Is that clear? Now, the whatever work you're going to complete, remember you are expected to do it do that in the vacation time, and it should not coincide or it should not overlap with your present theory classes. Also, if you still have some work that you can do, what I would suggest is definitely take up some, or you can do some initial work about your project or about the mini project right now, and do most of that and dedicate most of your vacation for the industrial training part that you can decide after the dates of the other issues have been announced. Okay, that is one. Then yeah, I think these were the different points that you had laid down. I hope I have answered most of the questions. You can also, if you are in and around Manipal, and if you're allowed to travel, and if you are capable, or if you're able, or if you have any contacts with any of the incubatees, if any system startups under MUTBI, that is also taken. You can definitely do that also. Working remotely is also definitely going to be considered this time given the scenario.
Excuse me, ma'am. I have a question. Yeah. Ma'am, for the industrial training, if we manage to get something from an actual company, and you're saying that it shouldn't overlap with theory classes, but we don't even know the summer vacation dates, so what do we tell them?
If you can wait until then and then take it up, good enough for you.
Ma'am, as it is, opportunities are not coming, so.
No, you have to take a call about it.
It won't be accepted if it overlaps with this theory class period.
Chances are less. But you know what? I would suggest you need not really leave that opportunity. You can take it up. Maybe during the vacation you can still do something.
Okay, understood.
Yeah.
Ma'am, thing is, even if you say during the vacation, we're still not sure about when that will be, and everywhere that we are trying to apply for, they're asking around, okay, what time, what dates can you be available, because we need this time to this time and stuff like that. That's why it's a big mess right now.
Yeah, I can understand that, but I can't really say anything official about it.
Ma'am,
the dates have to be given by the academic section.
I'm sorry, ma'am, please go ahead.
The dates will be given by the academic section.
Ma'am, so you're saying if we do something right now, then we can't like present it as industrial training, like if
See
we
what?
if we
That's
do
what I gave you another option for it also.
fine, fine, okay, understood. Okay, thank you.
Excuse me,
Ma'am,
ma'am.
I have a uh, ma'am,
Yes,
excuse
yes,
me, ma'am.
I'm here. Go ahead.
Yeah. So I'm in a situation where I can do an internship that starts now and I can continue it indefinitely. So is it possible that I can start my work now, but even during my vacations, whenever they may be, I'll be doing some work for them? Will that be accepted?
It will be accepted as long as your certificate mentions that period as the training period.
As the working period? No, my joining period will be this week, but then my ending period will be only after the vacation if I choose to.
Yeah, you can do it.
Also,
See, again, these things are not, see, we cannot really officially tell you, you can do that, you can do this, something like that. It's left to you. We've already mentioned what should be done, all that, right?
and one, okay.
Excuse me, ma'am.
Hmm.
Ma'am, so I've already completed an internship starting sometime in January or February. So it stretched a little bit into the start of this current semester. Will that be fine?
That's okay, that's okay.
All right. Thank you, ma'am.
All right, so I think I have answered most of your questions regarding
Ma'am,
industrial
I have
training. Again, if you
one
still have
doubt.
anything else, you please write to me on my email ID. I will definitely respond to you. You need not worry about, please don't really, write long emails regarding what project you did, what you did, how long, all that. As long as it is a 4 weeks project, it is well and good. Fine. So if there's anything else, anyway, I will be handling the rest of the classes for you. So you can definitely write to me on all this. All right.
Ma'am, am I audible?
Who is this? Basudha
Ma'am,
Palyasthal.
yes, ma'am. Ma'am, I wrote a mail to you explaining about my tax. I guess 2 or 3 of us from this branch have gotten it. I wrote the profile. Actually, in the circular, it's written like explain the project that explain the industrial relations of that. So I explained it to you in the mail. But like, is that accepted as industrial training?
I'll just go through your mail once again.
Okay, ma'am. Thank you very much.
Last question, ma'am. Do we have to get the industrial training or industrial training pre-approved by someone in the department before we approach it for it to be accepted?
As long as it belongs to our domain and you worked on it, it's all right.
Does machine learning count as a part of this domain? Because the circular that was sent earlier, that it didn't exactly clarify it.
What was it? What did you ask about?
It was a circular that was sent a couple of days ago, where that stated that even things like data science and machine learning would be considered. I just wanted a confirmation on that.
As long as you have learned, as long as you worked on it, it will be taken. Don't worry.
Okay, thank you.
Ma'am, you said projects that you have done for 4 weeks. What about student projects?
No, student projects are not considered for training. But yeah, if you have done it under the major student project, then I'll just clarify maybe in a day or two. I'll just confirm about it. I read your, who asked this? You can take that up. It will be taken up.
Actually, the thing is about Samsung Prism, it may last.
Pranav Narul, I was just going through your mail. Give me a day or two. I'll reply to you.
Okay, ma'am.
And you said something about major student project. What does that mean? Major and minor?
I'm not really sure, but this Mars rover and all that, again, I'm not sure if that comes under the industrial training or no. So that's, I said I will try to confirm about it.
Okay, ma'am.
Done. I hope I have answered most of your questions. Again, repeatedly telling you, please write either to me or to Dr. KMN for all other queries. Okay. Fine, all of you, please stay at home and stay safe. We will be meeting. I am doubtful of having my classes on in the next week because we will be having a workshop in the next week. So next Tuesday and Friday. However, it will be confirmed to you on Monday. Okay. Okay then. All of you stay home, stay safe. Have a great weekend at home.
Thank you, ma'am.
Thank you.
Thank you.
Thank you. Bye-bye.
Thank you, ma'am.
Thank you, ma'am.
Thank you.